Hello guys. How are you doing? Let me trust you're doing good. Today, we shall be talking about the power block diagram. This is a diagram which shows how the voltage flows within the motherboard, starting from the power port or when you plug in your adapter, or from the battery when not plugged in, until the voltage reaches the vehicle or the core of the CPU, the PCH, ICH, or any other component within the motherboard. Before we continue, in case you haven't subscribed to our channel, please, we are still requesting you, please subscribe, share with your friends who are interested in learning about laptop repair, because we shall be sharing a lot of content about the laptop repair. Sorry for that. Starting from the theory until the practical part of it. Again, we do laptop repairs. In case you have someone who has an issue with his or her laptop, please you can contact us. Our contacts is in the bio of our profile. Again, we do teach. In case you want to learn, you are highly welcome. You can contact us still. Then we can talk about the logistics or any other thing you need to have before you sign in for the learning. So far, we only available on site. That is, we don't have the online program. However, we are planning to introduce one. So let's go directly to the discussion of today. This is a diagram which shows how the voltage enters into the motherboard through the power port until it reaches the V core of the CPU, the PCH, GPU, or any other component inside the laptop motherboard. Here, this diagram, or these red arrows, shows the voltage flow. The red arrow shows how the voltage flows. The blue ones, this blue arrow, show the signal coming from the SIOs. Yes, because you can see you have a very thick blue signal lines coming from the SIO. Then you have a light blue signal line going towards the SIO. So these are the signals. So meaning what? This SIO is responsible for sending out the signal or controlling the power flow within the motherboard. This SIO can control the voltage flow, however, not directly. It can only control the power flow by sending out the signals or controlling the controller, power management IC, that is PMIC. The power management ICs are called PMIC, and those ICs are controlled by the SIO. This is system input output chip. This is a KPZ1. You have several of them. You have the SMSC. We have what's called the new button. We have Lenovo. We have ITE. Yes, and so on and so on. So here you can start with this one. This is a 230 watts adapter. This is not the voltage. Sorry for this. This is 230 watts adapter that can supply a voltage. This is what we call phase one. When you see this number one, it means this is a phase one. This phase one, or this line represent the phase one power supply or the phase one of power supply. So from here, we shall be having the power port. First, we start with the adapter, power adapter, which supplies the voltage from the wall socket. This is AC. It supplies in form of AC, where inside the adapter it can be converted to the DC voltage. Because the motherboard of any electronic device needs the direct current for it to power on. That's why that adapter can convert the AC to DC. Then it supplies the voltage through the power port or the DC jack, past the power inductor, that is thin film inductor or the power fuse, through the switches, that is MOSFET 1 and MOSFET 2, we have them here. Then to current sense resistor. So here still we shall have current sense resistor. Those components, and that, of course, we have a charging IC, which is placed somewhere around the circuit. That charging IC is responsible for controlling the voltage moving throughout the phase one line. So once we have the voltage going past phase 1, we will have the phase 2 line. The phase 2 line is starting from here, from the output of the phase 1, that is from the current sense resistor, all the way until we have the step down voltages, where we shall have step down 1, we shall have step down 2, and we shall have step down 3. We shall also have a step down 4 for the laptops which has the GPUs. But before we go there, I can have a very little explanation about this circuit too. So when not plugging, because you can see this voltage goes in, and again here you have two arrows going this way and coming, going to the battery, and an arrow coming from the battery. This is a voltage which is sent to the battery to be used in charging the battery. And when not plugged in, the laptop motherboard or the laptop will depend on the voltage coming from the battery. That's why we have this voltage coming from the battery. So this one is a charging voltage, this one is a discharging voltage, or the voltage which is sent into the motherboard. Sorry. So I believe you can see this one. This is called charging enabled, and here is called SM bus. This SM bus, this is a signals coming from the SIO towards the battery, and still we have the signal coming from the battery towards the SIO. That's why this arrow is two arrowhead. It has the arrows in both sides, because we need signal going towards the battery and others coming from the battery. This SM bus does the communication between the battery and the main motherboard through the SIO. This IC is responsible for giving us the information about the battery, whether it is fully charged, not charged, and any other information we need from the battery. This line also, the SM line also contains the signal which are used to monitor the temperature of the battery, and still it contains this SM bus, it has three lines, that is the temperature line, clock line, and data line. And all those are responsible for communication between the battery and the main SIO. Here we have a signal coming from the SIO towards this phase 1 of power supply. This is the entire phase 1 of power supply. This signal, this is called charging enable. So this is what enables the phase 1 or the charging IC to charge the battery. That's why we need this signal. Again, so let's just go to this first step down of the voltages. At this phase, this is the phase 2 of power supply. We will have 5.0 and 3.3 voltage. These voltages, we normally call them always on voltage, because these voltages are always available so long as you plugged in your adapter or you have the battery plugged in. So these voltages are always available. And these voltages, normally the 5.0 voltage is sent towards the operating circuit for the ICH. This is input control hub, which can control the power pattern and many other signal, or even it can also control the input devices and the output input output devices, including the keyboard, the speakers, the earphones, or the audio ports. Yes, so that's why we have the always on voltages. Moreover, we have also the 5 voltage. This is 5 voltage suspension and 3.3 voltage suspension. So this one can be used to. This voltage is sent uh, towards the network line or the sound line. So that is the step 1. And out of here, we shall have the 3.3 voltage, which is sent to the power on the KPC, the SIO. Yes, SIO powers on or operates under the 3 voltage supply. So the maximum voltage you can find within this SIO is the 3.3 voltage. That's why you can see this voltage is coming from this step down 1. You can see the arrow. The arrow points at the direction where the voltage goes. So from here, step down 1, We have the 3.3 voltage going towards the SIO. This is the voltage as supply. Still from the SIO, we will have the power pattern. So here we'll have the signal for the switching on of the battery of the motherboard, sorry. Yes. So that switch or the switch operates under the instruction from the SIO. This chip is responsible for switching on uh, the motherboard. So the switch is connected directly here and it is controlled by the ICH. That's why you have the power pattern going towards the ICH. Then from there, let's have a look at the step down 2. Step down 2, that is where we can get the voltages for the RAM. So this is the RAM circuit. So step down 2 is the RAM circuit. And of course, you can see the signal coming from the SIO. So meaning this step down 2 still is controlled by the SIO. As you can see, each and every step down line has the signal from the SIO. At the same time as the signal going towards the SIO, because each and every circuit communicates with the SIO. Yes, whether you have the insufficient voltage or you have enough, or you have any issue concerning those lines. It's most of the time it's about the SIO. So in case you're missing the 5 or 3.3 voltage or any line, sometime you might find because you're missing some voltage because of this SIO. Again, there are some instances where you can find you don't have any voltage. So long as once you plugged in, the voltage cannot be switched from MOSFET 1. And even after you've done all the diagnostics way, maybe you've looked at MOSFET 1 and 2, but still the voltage doesn't go beyond the phase 2 power supply. Most of the time you find that issue, it's because of the SIO. Because this one, if it is faulty or if it is dead, it cannot control the voltage flow. It cannot regulate any voltages within the motherboard. Still, you might have a problem with charging because you can see we need this SIO to communicate the information about the battery or to control the battery with the entire motherboard. So at step down 2, we can have several voltages depending on the RAM type we have. As you can see here, this step down 2 supply the voltage for the DDR3. So this 1.8 voltage, this is the voltage for this is operating voltage for the DDR3. As you can see, this is 0.9 voltage, so this is the terminating voltage for DDR3. Yes, in my previous video, I explained about the voltages of different RAMs. In case I had, for example, let's say DDR3L. DDR3L, I would have had, sorry, this is not DDR3, this is DDR2 because of 1.8 voltage. DDR3 or PC3 has 1.5. So this one is PC2. It has a terminating voltage of 0.9, operating voltage 1.8. PC3, it has a operating voltage 1.5, then here 0.75. PC3L, I will have had 1.35 and here 0.65. And for the PC4, I will have had 1.2 voltage and here 0.6. That is half of the operating voltage is the terminating voltage. For DDR5 or PC5, we will have 1.1 voltage here, and then here we will have 0.55 voltage. So I will not go into details about this because I had already prepared a video explaining about the RAM voltages. Then let's have a look at this another step down volt line. Here, this is the circuit which this represents the circuit which supplies the FICO. The FICO is the core or the inner core of the CPU. So these are the CPU voltages. You have several of them. You have 0.8 voltage. Sometimes you have 1.05. Yes, this is the voltage which goes into the inner CPU. because you can see this one, the output of this circuit is 0.8. So here the input is 19 because this is the main power line. Yes, as you can see, this broken line represents 19 voltage. So this is the line which represents 19 voltage. Then you can see that broken line, it is just the input of every step down line. Step down one, you have 19 this side. Once you have the output, we will have a different one. And you can see this broken thick line. Then the output will have a different value. That's why now it's continuous because it has been regulated. Yes, within this circuit, the step down circuit, we will have an inductor which regulates the voltage. And also we have the BD controller, that is power delivery controllers, which are responsible for stepping down the voltages which are depending on how much it is needed beyond that circuit. That's why you have a circuit here which is responsible for stepping down a voltage to a line of 5.0 and a line of 3.3. Here we'll have a PD controller which is responsible for stepping down to 19 voltage to either 1.8 or 1.35 or 1.5 or 1.1, whichever, depending on the type of RAM you have. But for the CPU, we normally have the voltages which are the same. However, different CPU, that is the i3 CPU, will use a different voltage with the i5 or i7. However, it's insignificant, though they are different, but it is insignificant. So that one should not give you any problem. And again, we will have another step down line for the GPU. In case this motherboard had a GPU, we will have had another circuit which represents that the voltage for the GPU. So guys, I don't know whether you've understood something here. Okay, of course you've understood. We have the SIO which controls all the power within the motherboard. So they don't, the SIO doesn't control direct power, but it sends out the enable signals. These are the enable signals. Yes. And then this one coming from those circuits. So once the enable signal is sent to this circuit, the circuit confirm if that signals are good for if the voltage is good, it confirmed back to the SIO. That's why we have power good. Okay, signal. So these are the signals coming from those circuits are called power good signals because those signals confirms the voltage output are correct voltage. Right? Yes. So guys, let me trust you. At least you've gotten something about the bar block diagram. This is actually the voltage within the motherboard is not represented this way. I know it will have a different arrangement within the motherboard. However, the functionality are the same. If you will be able to identify the main power line, which carries the 19, it will be easier for you to confirm the step down line. Because whenever you have a circuit, when you see any stacked inductor within the laptop motherboard, every stacked inductor, it contains a circuit by itself. So every stacked inductor you will see, it represents a circuit. So this circuit here, this step down line, this step down circuit, it represents a PD controller IC or MOSFETs. It represents some protection capacitors and resistors. And also it has a stacked inductor, which is responsible for voltage regulation. Yes, after the 19 voltage is stepped down, it is channeled towards that stacked inductor before it is directed um, to the correct chipset or to the correct line which is needed within the motherboard. So guys, thank you so much. Let me trust at least you've gotten something, and I'll really appreciate you guys. If you find this content useful, please subscribe to this channel because we shall be sharing a lot of tutorials, be it the theory, be it the practicals. So please Thank you so much for being patient, and see you in the next video. And still, if you haven't subscribed, please subscribe. And still, again, if you have an issue with your laptop, you can send it to us. Yes, we receive laptops from every part of the country. Even if you are in the village, you can send it to us. We'll repair it and send back to you. And if you're interested in learning still, I said we are taking intake right now, so please don't miss out. You are highly welcome to join us. We need more team in the field. So goodbye and see you in the next video.